The people who write the MCAS love to ask about the speed of sound in different substances. First, let's make sure we know where we can hear sound. So the question here is, where can the big-eared guy hear sound? Here he is. This child is either yelling or crying. And what's the medium between here? It's air, isn't it? So can this big-eared guy hear that child crying through the air? Obviously, yes, he can. Can't he? Now I place him underwater. He's crying and he's listening underwater. Can the big-eared guy hear him cry underwater? Sure he can. It may not be as clear under the water because our ears evolved to listen to sound in air, didn't they? But we can still hear it underwater. How about this guy? He puts his ear right next to a piece of steel and someone's going to hammer it and whack it on the other end. Can he hear through that steel? Yes, he can. He can hear in all three places, can't he? But what we want to ask is this: where does sound travel fastest? Here, here, or here? Generally speaking, there are two things that determine how fast sound travels through a substance. That substance's weight, how heavy it is, and even more important, how rigid, its rigidity. You know what rigid means, don't you? You got a baseball bat here and some rope. Which one's rigid? The bat is rigid, isn't it? Because it's not bendable. It's very difficult to bend a bat, so it's heavy and it's not bendable. Sound will go fast through a bat. And this rope here is not rigid, correct? It can bend and move around. It's bendable. So rigid means not bendable. All right, so let's see. Let's look at this as like the NCAA basketball tournament or something. We're going to pair air and water in the first round. The winner, that means the place where sound goes fastest, will move on to the second round and face off with steel, and we'll get a champion in the end. Here's your video code, solid fast. Solid fast. All right, so let's see here. We have a container of air. This is going to be a blaring horn making noise. And the stopwatch is going to measure how fast that sound crosses to that big ear in air. And the same thing here through water. So let's see here. Which is heavier, air or water? Obviously, water is heavier. Which is more rigid, harder to bend? Well, they're both pretty easy to bend, but water is a little more rigid. So who's going to win? Where is sound going to travel the fastest? Sure, the winner is going to be water. Now it's kind of garbled when you listen to it, again, because your ears aren't used to listening to sound underwater, but water does, probably sound does travel faster underwater. All right, so this looks like water wins the first round, doesn't he? Now he's going to face off a very daunting opponent in steel. We'll change that now. Here's water, it's just like before, but now this is steel. Who's going to win here? Who's heavier? Obviously steel. Who's more rigid? Much more rigid. Very hard to bend steel compared to water, right? So who's the obvious winner? The obvious winner is going to be steel. Yes, sound will go faster in steel than in water. So here it is. Steel is the champion. So we see here, generally speaking, which substance, gas, liquid, or solid, do you think is going to be fast, is going to transmit sound faster? The answer is solids. And why? Because they're the heaviest and the most rigid, correct? What's next, do you think? Well, let's go to the slowest. Slowest, so what's the lightest one? Lightest and least rigid of these two remaining. Gases or liquids, what do you think? Sure, gases are definitely the lightest, and they're the least rigid. So that leaves liquids in the middle, doesn't it? So what this says, and the moral of the story is this. Sound travels fastest generally in solids because they're heavy and rigid, next in liquids, and last in gases. Bye.